As part of the Water Voices speaker series, geologist Jim Gross presented Up and Down the Florida Aquifer on February 29th in the Rivers Media Center at Florida Gateway College. Gross has more than 35 years' experience working in water resources and water supply planning for industry, academia, regional planning agencies, and consulting firms. This program is 1 hour, 40 minutes long.
It's probably well known amongst many people that geologists are really the original itinerant workers in the country, and we get around to a lot of places. So I've worked in a lot of states, and but 18 now in Florida. So how many people here tonight have been to a previous Water Voices talk? Show of hands. Yeah, okay. So we got some new people and some people who've been here before. So this series of talks, they're being sponsored, are really a great opportunity to clarify information about our water resources. And there is really a pressing need for clarity on this subject today. There's probably more sources of conflicting information today on key political issues than at any time that I can remember. And I probably don't really need to remind anyone here tonight that water is really a key political issue. Okay, so tonight's talk is Up and Down with the Florida Aquifer. And most of the information I will present to you tonight is actually factual in nature and comes from published reports, principally from the United States Geological Survey. However, I will interject a little opinion of my own here and there tonight, both on a personal and professional level. And what I'll try to do, and if I don't do this well, remind me, I'm going to try to clearly define where the facts are and where my opinions take off. So, a big picture view of our most important source of water. So the Florida Aquifer System, it turns out, is Florida's largest and most important source of fresh water in the entire state. Very, very important source of fresh water. And what do I mean by big picture view here? And what I mean by that is looking at the Florida Aquifer System as a whole. I think that too frequently in the past we have attempted to manage this resource from a very fragmented perspective, if you will, looking at just little teeny pieces of it here and there, rather than looking at it as a whole when attempting to manage it. And I don't think that this has served Florida all that terribly well. So from my perspective, we really need to be looking at the aquifer system as a whole when we're attempting to manage it for sustainable supplies. Okay, I'm going to have a variety of topics tonight on tonight's talk. We're going to look first at the Florida Aquifer System. We're not going to go into a lot of detail on this, just enough detail so that you understand what the Florida Aquifer System is, where it is, and a little bit about how it works. Then we're going to move on to see how much groundwater do we have. And what I mean here is how much groundwater do we have in the Florida Aquifer System. And how we actually address that issue may be a little different than some of you might expect. The third topic will be looking at withdrawals. We're going to start looking at withdrawals from all sources across Florida, but we're going to zoom down in particular, and we're going to look at the Florida Aquifer System and compare and see how important it is amongst all of the sources in Florida. We're going to look at how much we're withdrawing from the aquifer system. We're going to then look at to see who's pumping and how much. And then there's this odd topic that I like to call myths and consequences. What we're going to focus on here is some of the misconceptions that people have about our water resources, and in particular about the Florida Aquifer System. and what some of the potential consequences could be if we aren't watching what we're doing very carefully. And then finally tonight, I'll have a few comments about sustainability, particularly as it relates to the Florida aquifer system. I would say the first three topics tonight speak largely to the nature of the problem we're facing in terms of attempting to manage our water sustainably. And the next three speak more largely to the solution that may derive. So one of the themes of tonight's talk is just how finite our water resources, our water supplies actually are in Florida and in the world at large. Some of you may have seen this particular graphic. It comes from the U.S. Geological Survey website, and it's intended as an educational website for the general public. And what the GS has done here is they've illustrated through these blue spheres on the screen what we have in terms of our water on the planet Earth. So the largest blue sphere up here on the screen, floating over the middle of North America, it represents all water on Earth. All water on Earth. And what the GS means with this blue ball is all the water in all of the oceans, all of the ice caps, all of the lakes and rivers, all of the groundwater, all the water in the atmosphere, and all the water in all living organisms on the entire planet. The vast majority of it is, as you might expect, salt water. Now the next smaller sphere, the medium-sized one, this represents all liquid fresh water on the planet Earth. And it turns out now what we've done here is we've stepped down 2 orders of magnitude in the amount of liquid fresh water compared to all the water on the planet. So all liquid fresh water on Earth represents less than 1% of all water on the planet. And then the smallest sphere in their illustration here represents all fresh water in lakes and rivers across the entire planet Earth. So this, I think, really underscores the finite nature of our water resources and perhaps cues us to the notion that we probably need to be good stewards of water resources. Okay, let's start talking about the Florida aquifer system. But before I get started talking and describing what the Florida aquifer system is all about, what I'd like to do is just quickly talk about some definitions here. So first off, let's define what an aquifer is. All right, so we're all on the same page on what an aquifer is. And an aquifer is a body of rock that is sufficiently permeable to conduct groundwater and yields economically significant amounts or quantities of water to wells and springs. So that's the definition, pretty much the definition. It's a relatively universal definition. You'll find it in lots of books for what an aquifer is. An aquifer system is very similar. It is also a body of rock, but here we have a couple of different key phrases here. It has layers of varying permeability and acts as a water-yielding hydraulic unit of regional extent. Let's just walk through these underlined terms real quickly and see how they apply to the Florida aquifer system. Sufficiently permeable. Well, the Florida aquifer system is among the most permeable aquifer systems in North America. Few aquifer systems really rival the permeability of the Floridan, and most that do are comprised of basically the same kinds of rocks as the Floridan is, limestones. There are a few other types of aquifers that are similar permeability, and they tend to be made out of basalts and other volcanic rocks. Economically significant, our next term. Florida's gross domestic product is on the order of $850 billion per year. $850 billion per year. Now, I don't have any hard numbers that say, here's how much relies on the Florida aquifer system. But if I had to bet on it, I'd say it's probably close to half of that, $850 billion. And it wouldn't surprise me if it's larger than that, relies on the Florida aquifer system. So that term definitely applies. Varying permeability? Yes. The Florida aquifer system actually is divided up vertically into an upper Florida aquifer and a lower Florida aquifer. And typically, through most of its extent, there are layers of rock in between that tend to be less permeable. All right, regional extent, indeed it is. It's approximately 100,000 square miles in area, the Florida aquifer system, making it one of the largest aquifer systems in North America. And this is a map that shows the extent of the Florida aquifer system. This comes from a professional paper published by the U.S. Geological Survey just last year, professional paper 1807. So the light blue area shaded is the extent of the Florida aquifer system. That's that 100,000 square miles roughly. You can see that it underlies all of Florida, and it underlies portions of South Carolina and Alabama and Georgia as well. Now, the quality of water in the Florida aquifer system isn't as good as we'd like it to be everywhere, okay? So it's variable. So this particular map is from an earlier publication by the U.S. Geological Survey, and what it's showing is the quality of water in the upper Florida aquifer as of 1980. Upper Florida aquifer as of 1980. And it's doing this by showing us total dissolved solids, that's basically the minerals that are dissolved in the water, in shades of blue. So the lightest blue color is the least amount of dissolved solids and hence the best water quality. And the darkest blue is the greatest amounts of dissolved solids and the least quality. So we can see here that the best quality of water in the Florida aquifer system really is in northern peninsula and the central peninsula areas. And that's where the best quality of water exists. In the far southern portions of Florida, folks rely on different aquifers for their water supplies. All right, now why does the Florida aquifer system have better quality water up in the northern and central portions of the peninsula? Well, the answer to this largely relies on the extent to which the aquifer system is covered up by other formations, other geologic formations above it. And hydrologists use the term confinement. You can think of it as covered, confined, covered. And the hydrologists, what they do is they'll recognize varying degrees of how much the Florida aquifer system is covered by these rocks. So what we're going to look at is the lightest green portion of the map up here. So that's this color right here. And so would be areas like here and over Volusia County. So in those areas, the Florida aquifer system is basically exposed at the land's surface. So what that means, of course, is that rainfall can get right into the Florida aquifer system and recharge it very easily to recharge right there. Now where the aquifer system is covered up by as much as 100 feet of other formations, hydrologists say that it's thinly confined. And here, water can still get into the Florida aquifer system, but not quite as easily as where it's unconfined. And this darkest green color, which is much of South Florida, this is where the aquifer system is well confined. There's really little, if any, water going into the Florida aquifer system in these areas where it's dark green. And what's going on really throughout most of these regions is this is where the Florida aquifer system is actually discharging. So why is confinement important? Well, because in North Florida where it's unconfined, water can just rapidly get into the aquifer system. And what that has done is it's flushed out the salt water that was originally there when these rocks were formed and replaced it with lots of fresh water. So we have the best fresh water in all of Florida, in the North Florida and Central Florida regions. And so that's a great thing. That's really a great thing. But this confinement thing is also kind of a double-edged sword, because where the Florida aquifer system is unconfined, it also happens to be extraordinarily vulnerable to contamination from whatever activities we're doing at land surface. So we have to be really careful in these areas to protect the Florida aquifer system, especially in North Florida. Let's just zoom into North Florida really quickly because this map can't convey all the detail that actually exists in these recharge areas. So we're in the middle of that red circle there in Columbia County. That's where we're standing right now and sitting. And so we're on an area of the aquifer system that is thinly confined. So there is recharge going on right here, and there is the potential for groundwater contamination if we're not careful. Subject number 2, how much groundwater? And in particular, what we're looking at here is how much groundwater do we have in the Floridan aquifer system? Now, this is a question that I think I've been asked every single time that I've spoken in public over the years. Lots of people ask this question. And typically, when they ask this question, what's on their mind is, what's the volume of water in the aquifer? And they're thinking that somehow that the volume of water in the aquifer somehow relates to how much we can take out. So that what they're doing is they're associating a volume with the sustainable withdrawals from the aquifer system. Okay? That's really common for people to think that way because it's kind of the way oil and gas works. There's a finite amount there. When we take it out, it's gone. Well, it turns out that the volume of water in the Florida aquifer system is not the key factor to sustainability. Now, I'm not going to tell you it's irrelevant, but it's a very minor factor in terms of the sustainability of the Florida aquifer system. What is the key factor? Well, it's flow. The key factor indicating to us how much we can take out is how much water is actually flowing through the Florida aquifer system. So when thinking about the sustainability of this system, don't think of it as an underground lake. Think of it as an underground river. All right? Get that mental image in your mind. It's a river. And how big, Jim? How big is this river? Well, let's get another mental image in our minds. Imagine standing on the banks of the St. Johns River where it discharges into the Atlantic Ocean. And the St. Johns River, of course, it sloshes back and forth with the tides, but it has a net discharge of fresh water out to the ocean that's on the order of 6,500 to 7,000 cubic feet per second. That's a pretty big river. St. Johns River is the longest Florida river that's wholly within Florida. Right? So it's a pretty big river. The discharge of the Florida aquifer system throughout its entire range is more than 3 times the discharge of the St. Johns River. We are going to take a look at how those numbers were derived by the U.S. Geological Survey this evening. Much of the work to do that was actually accomplished in the 1980s as a cooperative effort between the USGS and the state of Florida and several of the water management districts. Okay? This was a very, very comprehensive study. One of the most comprehensive aquifer system studies that's ever been done. So the USGS looked at the geology, they looked at the aquifers and mapped them. They looked at water quality variations. We've seen that map already. It's just one of many maps. They looked at how big the withdrawals were from the aquifer system. And finally, they did some flow modeling using groundwater flow models that were extremely useful in helping us interpret how the Florida aquifer system works. So we're going to look at just a little bit of the data from this report, this particular report published in 1988. Before we look at the numbers for their water budget, I would like to just briefly touch base on where this kind of all happens. So I want to show you where water goes into the Florida aquifer system and where it comes out of the Florida aquifer system. And so the terms that hydrologists use for this are rather analogous to, say, rechargeable batteries. So where water goes into the Florida aquifer system, these are called recharge areas, and where it comes out, these are called discharge areas. Pretty simple. All right? Now, on this particular map, the USGS has shown the recharge rates in the recharge areas in shades of blue, from light blue to dark blue. And they've shown, analogously, the discharge areas in shades of gray, from light gray to dark gray. So the lighter colors are less recharge or discharge, darker colors are more recharge or discharge. Now it gets a little bit more complicated in this, so let's just do a quick zoom in on this map to North Florida. And here we're looking at kind of a key area in North Florida where we are right now today. And on this map, we can see there's a lot of recharge going on. There's lots of dark blue in here, right? But what's also going on that you really can't see in the other map is that not only is there lots of recharge going on up in this area, but there's also lots of discharge. So we can see the trace of the Suwannee River as it comes in from Georgia. It makes the big bend and heads south to the ocean. And we can see the Alapaha and the Withlacoochee, the northern Withlacoochee River. We can see the Santa Fe River here, and we can see the trace of the Ichetucknee River. These are massive discharge features. Now, this part of Florida has the greatest amounts of flow through the Florida aquifer system of anywhere in its 100,000 square mile area. There's tremendous amounts of flow going through here. And that is probably why people over time have viewed this area as a potential water donor for water scarce areas to the south. I'm not going to get into the politics of that tonight because I don't want to get fried. One more graphic here to illustrate the large amount of flow that goes on in North Florida. So on the left here, we have our map showing the confinement of the aquifer system in shades of green. And then on the right, we have a map showing where most of Florida's large springs are located. So you can see there's a pretty close correlation between where the Florida aquifer system is exposed or thinly confined and gets lots of recharge, and where all those big springs are located. Not one-to-one, but a pretty good correlation. All right, we are ready to look at the very simple water budget that was initially developed by the U.S. Geological Survey to calculate how much water is flowing into the Florida aquifer system. And this is really easy to understand, so I don't think anybody's going to have trouble with this. And they called this the pre-development water budget. And what they meant by that is that this was the water budget for the aquifer system before we started pumping water out of it with our wells. So pumping began in the 1880s. We can think of this water budget as representing essentially 1880 water budget for the Florida aquifer system, which coincidentally is 100 years earlier than the reference year for the USGS study, which focused on 1980 conditions. Okay, so we're going to just look at some very simple quantities of water here, and we're going to plot them all in inches per year. How much in inches per year? And we're going to look at these four things: rainfall, evapotranspiration, runoff, and Florida recharge. Very simple. So here's the incoming rainfall. This is what we have to work with. USGS estimated about 53 inches per year on average falling on the recharge areas. It's actually falling on the discharge areas as well, but that's somewhat irrelevant to calculating flow. So that represents 100% of the water that's available for our aquifer system water budget. Now, 36 inches of it a year doesn't stick around very long. It is either evaporated off the land surface in the bright sunshine of Florida, or transpired up through the roots and out through the leaves of vegetation at land surface. So those two phenomena are lumped together as evapotranspiration. 36 inches per year, and roughly 68% of the incoming rainfall. A fairly representative number for evapotranspiration in Florida, although it varies higher than this and lower depending on where you are. Sometimes it rains really hard, or it rains really long, and some of that water actually can't infiltrate into the ground, into the aquifer system. And what it does is it becomes runoff to rivers and streams, and off it goes out to the ocean. So it doesn't become part of the water budget of the Florida aquifer system. So we have to subtract that amount too. That's 12 inches per year. 23% of the incoming rainfall as runoff. Now what we're left with after that is 5 inches per year recharging the Florida aquifer system, and that represents about 9% of the incoming rainfall on the recharge area. Those are actually pretty generous numbers if we were to look at other aquifers around the country where the percentage is lower than 9%, sometimes as low as 1 or 2%. And 5 inches per year is also a pretty generous amount to have available to us compared to other aquifers. Now 5 inches per year is a little bit of an awkward number to deal with for the rest of this talk. So let's get rid of it and let's replace it with something that we can use more readily. And the units we're going to use here are billions of gallons per day, BGD. All right? So our 5 inches of rainfall across the recharge area equates to 14.8 billion gallons per day of water. Okay, now let's talk about withdrawals from the Florida aquifer system. And the source of our data for this is going to be another USGS report. I lean heavily on the USGS for my sources for this talk. And this particular report was published in 2014, and it documents water withdrawals, use, and trends in Florida. And the reference here for the study is 2010. So what we're looking at is what happened in 2010. All right? Now, the author of this particular report is Rich Morella. He's been doing this for years. I consider him to be one of the foremost authorities on water use on a statewide basis. The water management districts have pretty good authorities on this in their particular districts, but the only agency that's integrating this information across the entire state right now, and actually historically, has been the U.S. Geological Survey. And they've been doing this for about 35 years, and Rich has been doing it for most of that time. So what we're going to do is start with total withdrawals from all sources. Now, we wouldn't have to necessarily do this if we're focusing on the Florida aquifer system. But what I want to do here is highlight a few things. I want to highlight which sources have critical constraints on their availability, number one. I want to show how important groundwater is to Florida. And thirdly, I want to show how important the Florida aquifer system is as a freshwater source in Florida. So we'll start with total withdrawals, and we'll work our way down. So we're going to break first off the total withdrawals into saline sources and fresh sources. I've got fresh bold here in bold white letters to emphasize the fact that this is a significantly constrained resource, the freshwater resources in Florida. We can think of the saline water resources as being essentially infinite. They're not infinite, of course. We looked at the USGS sphere. But with respect to how we're using saline water, it's essentially an unlimited supply for us. And then we're going to break the fresh up into surface water and groundwater. And in a similar fashion, groundwater in Florida today is the more seriously constrained resource. We have surface water available to us. We're using some of it. We probably could use a little bit more from some of the sources without getting into trouble. So it's less seriously constrained than groundwater is. And then finally, we'll take that groundwater and we'll break it up into the Florida aquifer system and the other aquifers combined. And I don't mean to imply that the other aquifers aren't constrained, because they are, but we're just going to focus here at this point on what's going on in the Florida aquifer system. So let's start with our first pie chart. We're going to look at pie charts basically for those three things: fresh, groundwater, and Florida aquifer system. And what we're going to see is that the pie charts for each of these are significantly different. You might not expect that, but they are. So let's go to the first pie chart. This is all water. This is saline water and freshwater sources. We're pulling out 15 billion gallons a day, or at least we were in 2010. And saline water actually is bigger than freshwater. We're pulling out more saline water. Almost all of that is for electric power generation. Almost all of that is surface water. So we're using 6.4 billion gallons per day of fresh water in Florida. And that is a significantly constrained resource. It's 43% of our total withdrawals. Now let's look at fresh water alone. So here's just fresh water, a constrained resource. We are using more groundwater than surface water, as I think I may have mentioned earlier, and roughly 2/3 of our fresh water comes from groundwater supplies. It's about 65%. So there's our 6.4 billion gallons a day. Now let's just look at the groundwater. All right? Here we can see that it's pretty clear that in dark blue, the Florida aquifer system is by far the largest source of water for Florida. And it's close to 2/3 of the fresh groundwater that we withdraw statewide. 2.6 billion gallons per day from the Florida aquifer system. Our withdrawals from the Florida aquifer system represent 40% of all freshwater supplies. And this map shows us where in Florida the Florida aquifer system is the principal source of supply. Shaded light blue, not the sole source of supply, but the principal source of supply. So you can see a lot of the Florida Peninsula and the Panhandle relies on the Florida aquifer system. And this is where most of the 2.6 billion gallons per day is being withdrawn, but not all of it. There actually is withdrawals in areas outside this blue shaded area, principally for agriculture. Now let's quickly compare the map we looked at before of water quality and compare it to where the Floridan is the principal source of supply for just about all uses. When we compare these two slides together, it becomes pretty evident that the Florida aquifer system is the principal source of supply everywhere in Florida, subject to water quality constraints. All right? Another way of saying that is it's the preferred source of water in Florida, subject to water quality constraints. Okay, we are now in a position to compare the water going into the Florida aquifer system to what we're withdrawing from the Florida aquifer system. We've looked at the numbers, so we're ready to compare, to review, compare, and discuss. Recall that the USGS had come up with 5 inches per year as the average recharge rate, which equated to 14.8 billion gallons per day. Well, let's just look at Florida. So let's just do a broad brush assumption here about how much of the recharge is in Florida, recharge area. And roughly 90% of the recharge area for the Floridan as a whole is in Florida, roughly. That's not a very precise number, but it's a representative number. If we were to just make an assumption to say that roughly 90% of the recharge occurred in Florida, what we'd get here is a number of about 13.3 billion gallons per day. This is not a precise water budget, but it's a very representative number. And here's our 2010 withdrawals of 2.6 billion gallons per day. It doesn't take a lot of higher math to compare those two. So our 2010 withdrawals represented about 20% of the recharge that GS calculated for the pre-development condition. Now, I should say that the water budget has changed a little bit since pre-development times. There's actually been some induced recharge that's occurred by our pumping the aquifer system. And this might be on the order of around 10 to 15%. I think the number that the GS came up with was about 12%. Okay, so the pie is a little bit bigger, not a lot bigger, but a little bit bigger. But nevertheless, I think it's fair to make an order of magnitude comparison of recharge and withdrawals. So, 20%. is this a significant number? I mean, is this important? Does it mean anything? All right? Well, I mean, some people might say, gosh, we've got 80% more to go. We're not in trouble yet. We're not even halfway there, right? Well, let's stop and pause and look at a little bit more information here. So first, consider when we pump the Florida aquifer system, where does it come from? Where does it come from? Well, the GS has stated very clearly in more than one study, it really comes in the Florida aquifer system from a single place. It comes from an essentially equivalent reduction of discharge to natural systems. So when we take out a certain amount of water, what we're doing is we're diverting that water from discharge to natural systems. This is a fairly simple concept to get your mind around. The USGS looked at it in the 80s and came up with this conclusion. And in a publication that came out as recently as 2013, they said exactly the same thing. We're not depleting storage in the Florida aquifer system. We're diverting discharge to our wells. Now, this isn't a universal phenomenon. So if we were to look at, say, the Central Valley aquifer system in California, or the High Plains aquifer system from South Dakota, North Dakota, down all the way to Texas, we'd see something very, very different. What we'd see is massive depletion of storage in these aquifer systems, something that is simply not happening in the Florida aquifer system. Totally different behavior. Now, getting to the 20%, let's see if that has any importance whatsoever. Well, the water management districts over the last 20 years and longer, in their responsibilities for looking at impacts to water resources, have had to see at what levels of withdrawals that there is impacts to natural systems. And what they've generally found is that once you get to about a 10% reduction in discharge to natural systems, we can recognize harm in these systems, right? About 10%, we can recognize harm. Okay, and that's not really necessarily compared to the pre-development state. It's often compared to a much later time where that 10% is applied. And what they've also found is that when we start looking at reductions of flows and levels on the order of 15%, we're typically merging on the domain of what's known in Florida water law as significant harm. Lots of MFLs around the state have been hinged on a reduction of about a 15% decrease in flows. So you can see these numbers of 10 and 15% are lower than that 20%. So I would say that if there aren't any red flags going up in your minds right now, there at least probably should be some yellow flags saying, yeah, 20% is probably a number we should be looking at pretty carefully. Okay, before we move on to looking at who's pumping and how much, let's just take one more little focused look at the water budget for the Florida aquifer system. And this particular illustration, once again, it came out of the 1980s work by the USGS. And what they did here was they prepared an illustration that showed how and where water discharges from the Florida aquifer system. And they did it in very, very simple terms. All right? So looking at the blue pie chart up in the right here, they just broke it up into three parts. So the dark blue color, or light blue color, depending on how you see it, represents discharge to springs and rivers. And discharge to springs and rivers is actually something we can measure. We don't measure all of it, but we measure a lot of it. So we can be fairly confident about a discharge to springs and rivers. Now in the dark gray, they mapped or calculated what they called diffuse leakage. Or what they really called it was diffuse upward leakage coming out of the upper Florida aquifer, right? Okay, and so this is discharge coming out of wetlands and swamps and things of this nature that's actually flowing. We can't measure this, but we can get a good handle on it using groundwater flow models, and this is what the USGS did. And finally, the third piece of the pie, in this sort of gray-blue color, that's us. That's our wells. That's our pumping. So this particular chart up here is for the Florida aquifer system as a whole. And the numbers are probably hard to read, but there was a discharge on the order of 24,000 cubic feet per second going through the aquifer system, and that represented 100% or all of it. But they went on to break it down into different sub-areas of Florida. And I would like to highlight for you what's going on in Central Florida in 1980. So you can see here that even as early as 1980, both in West Central Florida and in East Central Florida, that roughly 31% of what's flowing out of the aquifer system is to our wells. Okay? We rely heavily on the Florida aquifer system in this area. It's very important to Florida. But that was 35 years ago. More recent studies that were done in conjunction with cooperative regional water supply planning have showed that this number now to wells is roughly on the order of 50%. Now, in the report that it comes in, it's expressed as 50% of net recharge. There's no water disappearing here. What goes in comes out. Okay, so we can say recharge or discharge, and it means the same thing. So that's how much it is basically as of 2010 in Central Florida, much larger than the 10% and 15% that the water management districts have documented harm and significant harm. So yeah, it's something that we should be concerned about and watching, maybe doing something about. Okay, and we're kind of moving into the what are we going to do about it stuff, maybe. I don't know. We'll see. Who is pumping and how much? Well, we can't really talk about individual water users here because there's just far too many of us, right? So what we have to do is we have to lump things a bit. And if we wanted to talk about individual water users, we'd probably have to be here for several days. And I don't think anybody wants to do that. So to get out of here tonight, what we're going to do is we're going to roll up water users into different water use categories. But why even talk about water use by category? Is it even important? And I think it really is. And let me give you a case in point to illustrate why I think it's important. So for example, a lot of well-meaning people have recently focused on certain water uses that they think maybe are not suitable for Florida given our constraints on fresh water supplies. And you can probably imagine that I'm talking about bottled water here. A lot of people have gotten very upset about bottled water, would like to see it totally banned in Florida as a water use given our situation. Well, you know, I'm not a big bottled water user. There's my bottle. But on the other hand, we need to keep things in perspective here or we could waste a lot of time. Bottled water represents far less than 0.1% of all withdrawals from the Florida aquifer system. And it's really, I think it's really a lot smaller than that. It's probably closer to 0.01% of all withdrawals. So, you know, we spent a lot of time on this issue, and we could get rid of all the bottled water out of Florida, but what would we have solved? Essentially nothing. We wouldn't have made even a little dent in the problems of sustainability that we're facing today. So I think we really kind of need to keep our eye on the ball here and see, you know, what's going on in terms of water use. Okay, let's look quickly at our water use categories we'll use in lieu of individual water users. We have agricultural self-supply, public water supply, commercial and industrial mining self-supply, kind of a lumped aggregate category. Domestic self-supply, that's if you're not in a utility, you get your own well for indoor-outdoor use. Landscape, recreational, aesthetic, another kind of lumped category with overlapping things that are very similar. And finally, power generation. What do we mean by self-supply here? Maybe it's not entirely obvious. So maybe an example is the best way to illustrate it. So in Central Florida, particularly in Orange County, there's a lot of water, wastewater, that goes to wastewater treatment facilities. And that water is treated to a high quality, suitable for irrigation, and it's delivered to agriculture in this area, offsetting the need to pump high quality, fresh groundwater from the aquifer system. This is a good thing. Reuse is a good thing for Florida. But in this case, those growers are not agricultural self-suppliers. They're being supplied by a utility. So that's what self-supply means here. Okay, let's move on to total water use. And what we're going to do here is we're going to break down water uses by source for sort of really the same reason that I broke the withdrawals down by source. And what I want to do here is emphasize the uses that depend upon sources that are sharply constrained. So what we'll first do is we'll break total water use into saline water use and freshwater use, and then we're going to focus on fresh groundwater use. And the pie charts here will be significantly different from each other for these three things, the total water use, the total freshwater use, and the fresh groundwater use. And that, the fact that those are so significantly different from each other does have some implications for how we're going to need to manage our supplies moving forward. This is the total water use pie chart. And here you can see in an orange color that electric power generation is by far the largest use of water. But once again, as I said earlier, it's almost all saline water, and it's almost all surface water. Right? And we can see here that agriculture is the next largest user at 17%, and public water supply, third place, 15%. So if I didn't have any further information than this, I might think, wow, electric power generation, there's my problem. I really got to focus on that. I'd be wrong. Let's look at total freshwater use. Here we're looking just at total freshwater use. Now you can see that electric power generation decreases to 10% of the use of our fresh water. And now agriculture is in first place at 40% and public water supply at 35%. Now here you might say, aha, it's agriculture. That's what I have to worry about. Right? Now if I said that without any further information, once again, I would be wrong. Here's total fresh groundwater use. Now you can see that electric power generation has just about disappeared, and public water supply is now the single largest category. There's more to the story than this pie chart can actually tell you, because agriculture has actually been declining over the last several years. It declined significantly between 2000 and 2010, and for all we know, it has continued to decline since 2010. On the other hand, public water supply and all the other categories are increasing. All the other categories are directly linked to population growth. So what's going on is what's driving growth in water use in Florida today is not more carrots or citrus or anything else at the moment. It's us. It's people, growing people. That is the primary factor that's increasing our water use in Florida. It's likely to be the primary driving force for increased water use in the near term and perhaps even beyond. Okay, let's have some fun maybe, huh? Myths and myths and consequences. And I kind of call this myths and misconceptions and the consequences that might derive from misunderstanding our water supplies. Well, why would we even want to talk about this? Doesn't this sound like it's just a little silly? Well, over the years, I've had the opportunity to talk to a lot of people individually, a lot of people in groups, and talk to them and listen to them. And this has been great. I've loved doing this. But even more importantly, it's been an extraordinarily enlightening experience for me. I've learned a lot from talking to the general public about their views on water supplies. And one of the things that I've learned, quite frankly, is there are a lot of misconceptions about our water resources. And it really boils down to something that's quite important. And let me tell you why. At the moment, there's a lot of public money now that's up for grabs, purportedly to better manage our water supplies, right? That's the intent of it. And hopefully there's going to be more available in the near future because we really need it. We really need that money to fix problems. But not all of the projects that are being proposed are going to have much of a positive impact. And quite frankly, some of them that have been proposed are actually going to make the problem worse. So there's a lot at stake. We want to get it right. We need to get it right. Let's look at a few myths and misconceptions. Myth number 1. There is a large amount of groundwater flowing offshore. Sounds great, doesn't it? A lot of people believe this. Actually, there's very, very little water flowing offshore from the Florida aquifer system, or any of Florida's aquifers for that matter. The USGS estimated that only a half a percent of the flow in the Florida discharged offshore. Yes, there is flow that goes offshore, but it's very small amounts. In some areas, it's essentially zero flow. It's water that got there earlier and earlier geologic times, and it's just kind of sitting there. Why would it be important to know about this? Well, let me just tell you a little short story about this. I'm running out of time, so I better be quick. Back during the depths of the economic recession, there were investors who had managed to salvage money out of the marketplace, and they were looking to do things with their money to make money, to earn money with it, rather than just letting it sit idle. Okay, that's a good thing. That's a good thing. So they were getting quite creative during this time, and quite a number of them actually came in to talk to us when I was working at the St. Johns River Water Management District. And they all had some different ideas about what they could do to fix the problem. And one of the companies that came in, they said they understood our problems, that we were constrained in the Florida aquifer system because of environmental impacts, saltwater intrusion, and what have you, but they knew what the solution was going to be. They were to come in and drill into the Florida aquifer system offshore, pull out what they called a vast reserve of fresh water that's just sitting out there ready to be tapped. Now that sounds great, doesn't it? It sounds great. It would be great if it was true. Let's look at why this might not have been such a great idea. First off, as we can see from the bullets up there, there's very, very little fresh groundwater out there, and most of it's stagnant. If we started pumping from the Florida aquifer system offshore, the freshwater part that is there would be depleted very, very rapidly. Secondly, still the Florida aquifer system. So pump offshore, there still are impacts that propagate across the Florida aquifer system. So people have well fields on the coast, and there's lots of those people. They could still be impacted by drawdowns coming in, because they weren't going to go way offshore. They were going to go pretty close to the shoreline. So secondly, it doesn't really make sense for solving the problems that we already have. But thirdly, and this is most important, thirdly, this, as you can imagine, would have been a very expensive project. But the viable project life, very short. So short, in fact, that the bonds to finance a project like this probably couldn't get paid off before the water was gone. So, this project, if we'd fallen for it, boy, they thought they had us. It would have been a disaster for everybody, from investors to ratepayers. So again, stakes are high. We really need to be monitoring what our resources are all about before we start spending large sums of money on projects that really aren't going to do much, if anything, for us at all. Myth number 2. There is much less water in the Florida aquifer system now due to pumping. Now, I think I've already tipped you off to the answer to this one by saying we're not really depleting storage in the Florida aquifer system. So it's largely untrue. There's a little bit of storage depletion that occurs in the far northeastern corner of Florida, in areas where there's a very thick accumulation of clays, and we've dewatered some of those clays, and there's been some depletion of storage there. Very small amount. It's very insignificant at this time. So again, our pumping does not deplete storage, it diverts flow. And that flow, again, once again, is diverted from natural systems. That's where the water comes from. It's pretty simple. And as the USGS said in 2013, quote, negligible long-term volumetric depletion in the Florida aquifer system. Okay, why would it be important to know this? Well, once again, lots of projects are being proposed to get public money. And some of those projects include things like underground storage, which can be actually very good in places in Florida. You've probably heard about aquifer storage and recovery. It's very controversial with some people because there are a lot of issues associated with it. But in places where it will work, it's not a bad option. But for ASR, you generally need to be storing the water in a saline zone, and you generally need to be being able to recover all or most of what you put in to make this kind of a project cost effective. So when we look at those two criteria, what we'll find is across broad swaths of North Florida, underground storage in the form of aquifer storage and recovery is probably not going to make sense. So there have been proposals for it in North Florida. We really need to keep our eye on the ball for the locations where it's being proposed, because those projects could spend a lot of money that doesn't really do much for us. Okay, myth number 3. Everybody knows this is true, right? Florida's groundwater comes from Georgia. So many people think this is true. Must be true. Well, actually, very, very little of Florida's groundwater actually comes from Florida. It's just a tiny amount that comes in from Georgia. There is some that comes in, right? But nearly all comes from recharge that occurs in Florida, right? That's really what happens. So why would this be important? Well, Florida and Georgia have not exactly been best buddies over the last several decades on water issues. Mostly what we've been piddling around with and fighting over is surface water, and some of that's understandable. It's not understandable for groundwater. If we get involved in another fight over groundwater supplies with Georgia, we're going to waste a lot of time and a lot of money, neither of which are in abundant supply. And in the end, we'll get nothing from it, okay? So what we need to be doing with Georgia on groundwater is working nicely, playing nicely with them, because it's a shared resource, right? Shared resource. We don't need to be fighting with them over groundwater. And at the moment, Georgia is actually doing some things that are a bit more progressive than Florida is. So I like to say that, next time you hear that Charlie Daniels Band song, turn the lyrics around to Florida went up to Georgia and was willing to make a deal. All right, myth number 4. This is our last myth. The lower Floridan aquifer is a new and untapped source of supply. Now this myth, this hasn't figured in any of my earlier talks, because this is a new myth. It is neither. The lower Floridan aquifer has been utilized for years in Florida, in many parts of Florida, actually for decades. Jacksonville went to the lower Floridan aquifer just decades ago. Of course, now they're kind of sorry they did, but it's also used in Orange County and Seminole County, Lake County, and probably other areas that I'm not even aware of. It's been used a long time. It's not untapped. And here's one thing to consider. There's really not a lot of flow going on in the lower Floridan aquifer. And a lot of the fresh water that got there probably wasn't real recently. Think about sea levels 420 feet lower than they are today. What's that going to do for allowing fresh water to really penetrate deeply into the aquifer system? This establishes a new lower baseline for flow and flushes out a lot of that salt water. So that fresh water that's there today in the lower Floridan aquifer, probably a lot of it got in there 18,000 years ago during the last major advance of the ice sheets, all right, and some of the preceding advances. There's probably not a lot of additional flow going in there in many parts of the lower Floridan today. So it's not a high flow system that's going to last very long for being fresh. I have an anecdote on this one. I'm going to bypass it for now because of time. Last section, I promise, sustainability. So I've talked a lot tonight about some of the precarious issues related to our groundwater supplies. But all is not gloom and doom. Right? I want you to go home unhappy. Right? We do have the capacity to deal with these issues. None of this is really rocket science, although it will be complex when we put together the kinds of packages that are needed. So here I am going to move away from facts and figures and share some of my own personal perspectives here, which are based on many years of work in this field in places like California, New Mexico, Arizona, and 18 years here in Florida. I've had the opportunity to see what works and stuff that doesn't really work so well. So we're just going to look at just 3 essential things where we need to start on this, embark on this journey to getting towards sustainability. And I think these are imperative. They're essential. We have to build inclusive coalitions to work on this. We have to do this. Everybody's a water user. Everybody has a stake in the outcome, whether we achieve sustainability or fail. We all have a stake in the outcome. So if you want to talk to people, if you want to work on this problem, and want to go talk to people and try to make some progress, here's what I would suggest. Don't just go talk to people who you think see the world the way you do. Go talk to people who might see the world differently than you do. And when you go do that, spend at least as much time listening as in talking. Because I think what you'll find out, and it might surprise you, is there's more common ground here than we might imagine or suspect, right? I mean, really, all of us care about these issues. It's just that when we talk about solutions, they kind of hurt, right? They're going to hurt a little bit. But the alternative is going to hurt worse. Leadership at all levels is absolutely imperative. You know, we're not going to really go very far unless we have leadership all the way up and down the chain of command. What do I mean here at all levels? Well, I mean starting at the community level, like in rooms like this, moving up to local governments and regional agencies and state government, the legislature, the governor's office. We got to have everybody on board, or we're not really going to get very far. And a corollary of this particular element is that we need to realize, and I don't think many people do, is that the water management districts, they simply can't do this all by themselves. And they got a lot of great people, very, very competent scientists and engineers, and all kinds of other expertise, right? Really good people. They can't do it by themselves. Not at all. They have a big role to play, but they're going to need that leadership from the grassroots all the way up. And finally, and I know a lot of people aren't going to be happy to see this flashed up there, there really aren't any bad guys here. You know, we're all just water users. We really have to avoid the temptation to point the finger at other people, because you know it's really all of us here. So we have to avoid that. Now, of course, all of this is much easier said than done, right? Much easier said than done. Many of you have probably seen this before, but if we're going to make any progress on this, and this is not in any way, shape, or form going to be a wham, bang kind of thing. It's going to take years. It's going to take decades to do this, and it's going to be desirable for it to go slower than quicker. So we have to have sustained momentum here. Absolutely have to have sustained momentum. But this principle of the hydrological cycle has been a severe impediment to making long-term commitments to sustainability everywhere I have ever worked. So if we think about this cycle, this crazy illogical cycle, it's really logical if you think about it, not illogical. if you start with drought, and it lingers around for a while, pretty soon you got public awareness. It lingers around a little bit longer, pretty soon you got public concern. And if it really hangs on like a deep drought, then we get to the panic phase, right? And then, of course, all droughts end at some point in time, and it rains, and we go to apathy, and we go round and round and round. We have to break out of this cycle if we're going to make long-term progress. So we need to separate droughts from long-term issues. Let's look at the path we're on. We're almost done here, I promise. This is a pretty good representation of the path that we have been on for the last 60 years. This shows public water supply withdrawals from 1950 to 2010. And it's showing both surface water and groundwater withdrawals in two colors here, blue for surface water and green for groundwater. And they're added up and shown on the line above those bars. It's pretty easy to see that in only one interval of time did total water withdrawals actually drop. And that was between 2005 and 2010. I apologize for the numbers being hard to read. I ran out of time and couldn't recreate this chart. So it dropped between this interval and this one, the last two. All right. Why did that occur? Why did that occur? Not everybody agrees on why that occurred, right? So from my perspective, I think clearly a component of this has to do with conservation. Greater conservation funding, greater conservation awareness, greater conservation measures, all right? All good stuff, we need that. All right? Some people think that this is the beginning of a new trend in public water supply withdrawals, that we're going to see it continue to go down into the future. I would love for that to be true. Unfortunately, I don't think it is. And I'll tell you why. And neither, by the way, does the author of this report, Rich Morell, from which this graphic came from. And I talked to him just 2 weeks ago about this. He doesn't think it's going to continue into the future either. And he's probably the best source on what trends are going on in the state, in the whole state. So what happened between 2005 and 2010? Well, we all recall that we had the most severe, significant economic downturn that has occurred in this country and in the state since the early 20th century, the Great Depression of the 30s and early 40s, ending in World War II. Now, during this time, I talked to a lot of utility directors, because that was my job. I talked to utility directors and elected officials all the time. What some of these utility directors were telling me during the deepest decline of the recession, so like maybe around 2009, is they were seeing idle water accounts, read that as empty houses, on the order of 10% in their service areas commonly. Some were reporting higher numbers to me, 15%, and I think one actually reported a vacancy rate of up to 20% in its service area, an area that was really adversely impacted. So I think a lot of this downturn, and even the houses that weren't vacant, I mean, we were all hurting, right? A lot of people were hurting. I think there was a lot of discretionary reduction in water use, probably showed up as reductions in outdoor water use at this time. So my opinion on this is, unless we begin to manage our water supplies differently, this is not a trend that's going to be continued into the future. We're probably going to see those numbers bouncing up again when we get the 2015 numbers. Okay, let's look at population growth now, past and projected for Florida. All right, we're going to look at historic numbers that are shown in blue here, and the last two ones there are 2000 and 2010. Just for some amusement here, I plotted some very, very early estimates for what population in Florida was like in the 1500s and early 1700s. You can see in the 20th century there's been a dramatic uptick in population. No surprise. Where are we today? I don't have today's population, but it is my understanding that we just crossed 20 million people in Florida. So the blue line I just put up there, that's kind of a reference line showing basically where we are today in population. Remember, this is the driving force for increased water use in Florida, is population growth right now. Could change, but that's what's going on now. Here are projections of population moving forward to 2040, and these were produced by the Florida Office of Economic and Demographic Research. And so these go out to 2040 and suggest that these are medium projections, not the high projections. They also have high projections that are higher than this. These are the medium projections. That we'll be at 26.1 million people in Florida in the year 2040, which, by the way, is pretty close to the planning horizon that the water management districts are supposed to be looking forward to. They're instructed under state law to look 20 years into the future. Now, a lot of them right now are looking at 2035, but this is not far from where the water management districts are supposed to be planning. Where are we going to get our water in 2040? If we don't do anything differently, we would likely see pumping from the Florida Aquifer system increase from 2.6 billion gallons per day to 3.6 billion gallons per day by 2040. And there's reason to believe that it could be higher depending on where that growth actually occurs. Let me elaborate just briefly for you. Traditional patterns of population growth in Florida have sent people to coastal areas, typically southern coastal areas of Florida. What's going on now? Climate change and sea level rise. A lot of people are just now awakening to the reality of climate change and sea level rise. And I'm not saying that the growth today has slowed down, but I think there are a lot of indicators to suggest that these areas are not necessarily going to be the magnets for growth that they traditionally have been in the 20th century. We could see those magnet areas now move to higher ground that relies on the Florida Aquifer system. The time for strategic planning in Florida is now. All right, let's summarize quickly. Our freshwater supplies are most decidedly finite in nature. Unless we want to desalinate ocean water, we have what we have and no more. At some point in time, I think we will turn to a much larger utilization of seawater desalination, and I am hopeful that there is technology emerging that will make it much more cost-effective than it is today. There are some very promising developments on the horizon. Pumping from the Florida Aquifer system reduces discharge to natural systems. We've seen this conclusion by the U.S. Geological Survey now. It's not a point of contention. This is just what happens. Here's a point of contention. If we want to protect natural systems, it follows. This is not rocket science either. We'll have to limit groundwater withdrawals. We don't really have a choice here. We have to limit them. Whether or not we use seawater desalination or any other technologies, we will have to do this if we want to protect natural systems in Florida. Now, a lot of people have said, and I agree, that healthy natural systems really equates to a healthy economy. Right? Lots of people have said this. I'm not the first one to say it. And I think it's true. I really think this is true. But I think it goes beyond just a healthy economy. If we allow our water resources to be depleted and disappear, we become more impoverished aesthetically as well, right? We lose out on all these fine features in Florida. And I think it even goes just a little bit even beyond that. I think if we allow this to happen, we become more impoverished spiritually as well. Okay, let me close with a few upbeat comments. It's time for those, right? Would you agree? So I attended the 2-day University of Florida Water Symposium this month, a couple weeks ago. And it was great. I was really glad I went. It was great. Great speakers, great talks. I think that it's fair to say that the overall tone of the symposium reflected a growing sense of urgency. Okay, growing sense of urgency about water issues. And I'll say, you might say, sure, this was just an academic event. But I will tell you that the concerns that were expressed were not just by the academic people, right? The academic people have greater liberty to speak their mind openly. I would tell you that even the state agency people that I listen to talk seem to understand that we are living on borrowed water and borrowed time. So maybe these are just subtle indicators. I don't know. But there does seem to me to be an emerging consensus, a consensus that we must manage our water supplies more wisely than we have. There's no question whatsoever, we already have the knowledge and the tools to do so. Right now, we have that. Everything we need to do that. From my view, the only question now is whether we have the wisdom and the will to do so. Thank you for your time tonight, and thank you for all that you do to make Florida a better place to live. I think that's my cue to take questions.
Thank you. Yeah. We're going to share the microphone and fielding questions. I'm going to repeat a question that you have from the audience, and Jim is going to answer. Before I get into that, I just really want to thank you, because the time, the knowledge, the wisdom that you're asking of everybody else was very present in your presentation tonight. So thank you for spending the time with us. We do really appreciate it.
My pleasure.
Okay. Yes.
The purpose of the Ichetucknee Alliance is to restore, protect, and preserve the Ichetucknee River and its associated springs. Based on what I heard tonight, the figure of 20% more groundwater pumping now than pre-development is about the same amount of flow that the Ichetucknee, I think, has lost. Where do we get our most bang for the buck in trying to restore the river? Do we concentrate on public water supply? Do we concentrate on agriculture? Do we do both? What is your best advice for us tonight?
And you really want me to parrot that back?
Biggest bang for the buck.
Biggest bang for the buck.
Can you paraphrase her question and go from there?
Yeah, the question is, how do we get to sustainability given that there has been impairment of flows in these spring systems? How do we get to a more sustainable flow from these systems to make them the more vibrant and healthy that they once were in Florida? Okay, and that's not an easy question to answer. That's a tough nut to crack. I don't think there is any simple answer here. I think it's going to have to be a whole suite of things on a scale that we have not really seen in North Florida, and really perhaps have not even seen in Florida at all to date. So it's going to have to incorporate a whole variety of things. I don't think we're going to be able to categorize or pick out certain water users and say, you need to bear a greater share of the burden here. I don't think that's going to be politically acceptable. If we are going to agree that we need to reduce overall withdrawals from the Florida aquifer system, we're going to need a toolkit that includes a whole variety of things, including economic incentives for people to withdraw less water from the Florida aquifer system. And we need to be encouraging partnerships, public-private, ag, non-ag, all kinds of things. It's a huge bag of tricks that we're going to need to develop. And we're going to need to look at what's most effective for the dollar when we do this. So I think that before we do anything, we should be doing that strategic planning that I call for, looking at the economics and the finance and what can be done that has the least overall adverse impact to our economy. And once again, if we don't do anything, ultimately the economic impacts will be worse than doing nothing. But what we don't want to do is sink the economy in Florida. We want to keep it healthy and robust. And I think we can do this. I really do think we can do this. But it's going to be a very comprehensive thing, a package of things that will need very, very broad support amongst water users. And it will take time. It will take time to transition this. I have said to people that if we were to stop putting nutrients on the land surface today, we would see the benefits of that very quickly, very quickly. I mean, because some of the spring flows, the distance from where it recharges the aquifer to where it emerges again, very short. And so we would realize benefits very quickly. But in getting those flows back to healthy levels, that's going to take longer. It really is going to take longer. I'm thinking 10 years is not an unrealistic time frame for that, and it could potentially be longer depending on a variety of factors. I'd like to see it go faster than that. I just don't feel that it's likely to happen.
Any other questions? Yes, sir.
As unpalatable as it sounds, what are the potential avenues for direct potable reuse in lieu of withdrawing groundwater from the aquifer?
What are the opportunities for direct potable reuse? They are immense. Direct potable reuse is not occurring in Florida right now. It's not really occurring anywhere but a very few limited areas in this country right now that we're desperate. Texas, place where my wife and I got married in New Mexico on a mountaintop back in 1986. They ran out of water a long time ago, and they're doing direct potable reuse there in that town of Cloudcroft. The technology for direct potable reuse is with us today. We know how to do it. We can do it. It's easier and less expensive than desalinating seawater. And the product will exceed customers' expectation. And it can be done safely. But what we don't have today is the regulatory infrastructure to assure that there are adequate, overlapping, and redundant safeguards to make sure there would never be any releases of unsafe water to the public in the form of drinking water. Those are still in development. Places like California and Texas are kind of taking the lead on that right now. And we should be seeing some of the results of that very quickly, because I do stay in touch with some of my colleagues who are working on this directly. There's immense potential there. But one tool in the tool bag. It's direct potable reuse. While there's immense potential, that alone will not solve all our problems.
I was concerned about the statement about agriculture and its self-supply, 17% there. But you said that it was in decline. And I'm thinking about all the land that's being bought up now for agriculture and cattle in large tracts of land, and I don't know when you're referencing the decline and what's taking place immediately.
Yeah, no, that's absolutely true. In this area of Florida, agriculture is expanding at the moment. There are a lot of growers moving in from out of state to grow crops that they couldn't, like California is an example. For carrots, I believe, is the example that's frequently given. So when I said that agriculture is in decline in Florida, what I meant is that overall, in Florida as a whole, agricultural water use is declining since 2000, and it's declined quite significantly. The major components of that decline have to do with citrus declines because they've been so severely impacted by diseases that have come about over the last 10, 11 years. And the answer to that, I know IFAS at the University of Florida is working on this. I guess I'm not sure what I think about that. If IFAS saves citrus and it comes back to where it once was in Florida, we really got a challenge on our hands, right? So most of that citrus is in the south part of the state, But still, they rely on groundwater in major areas, and a lot of it's Florida aquifer system. Yeah.
Yeah, Jim, I appreciate the technique that you've used to come up with the numbers. One does concern me, and that is right where you started, at 53 inches of rainfall. And that data that you used from Geological Survey 1980 report, that means the water data was made from 60s, 50s, 40s. Okay, that's 40, 50 years ago. And I know that when we do projections now, our models are looking at the past 25 years. I haven't seen anything above 43, and that's 10 inches less. So if you start out with 10 inches less than what you started with, the problem's a whole lot worse. Now, two comments I'd make. I'm well aware that when we've been drilling recent wells, we're getting a lot higher salt values. They've jumped from 200 parts per million to about 1,000. Okay, that's a sign that there's less fresh water, and you can answer that to me. Then the other issue is all through the Panhandle, wells are being moved back from the shoreline, and cities are moving those wells back because of intrusion issues. So my point is, maybe we really have passed that point in terms of global warming, that our average rainfall really isn't 53. We're pretty sure we've gone through 25 or 30 years at 43. So where does that leave us? A lot less water than what you say.
It's a very good point that if we looked at more recent rainfall data, we'd get some different numbers that might not look quite as cheery. But Dave, it gets even worse than that. Let me just tell you, the firm of Tetra Tech did a study not long ago, just a few years ago, and they looked at the impact that climate change is likely to have on recharge in Florida. And their conclusion was that not because of sea level rise, but solely because of temperature increases, that first piece of the water budget, the evapotranspiration, is going to go up. It's going to go up, and there will be less water available for recharge. So yes, there are reasons to believe it could be worse than using the data from the 1980s. And I guess all that really means is that it's time to do some strategic planning right now. Absolutely. What was your other comment about the rainfall and saltwater intrusion? Sure, saltwater intrusion is a huge issue in Florida, and this is not new. You know, one of the things that I did when I was in charge of long-term regional water supply planning at the district was actually sort of catalog that across the district. And every time we updated the district water supply plan, the situation was worse than 5 years earlier. You know, there were more wells that were getting salty, and the wells that were already salty were getting saltier. All right, and you're right. It's typically in the coastal areas we're seeing that. But let me say this: the myth that the lower Florida aquifer is a new and untapped source of supply could be a very dangerous proposition if we don't handle it right. Because the salinity in the lower Florida aquifer system is, for the most part, dramatically higher at the base of the lower Florida than anywhere in the upper Florida. There are a few places on the peninsula where there's some reversals around the edge of that freshwater area in the upper, but generally speaking, when you get down into the lower, you're talking about very salty water. And if we're going to go about not just replacing wells in the upper, but putting more wells now in the lower, what we're going to be doing is drawing up salt water from the base of that lower Florida aquifer system very quickly, and that I don't think is a sustainable option for Florida. I think there are opportunities to use the lower Florida. I will say yes, but we have to think really strategically about the trade-offs. If you're sitting right next to an MFL water body and you can't get a drop of water because you're impacting that MFL water body, maybe you can move your withdrawals to the lower Florida and spread out those impacts to a broader area. But that's kind of a strategic, substitution from upper to lower, not a let's keep everything in the upper and let's do more in the lower type of thing.
Jim, you said that drop in water use was primarily due to economics and empty houses and so forth. That, I think, is probably true in the southeast and south, but not less true perhaps around Jacksonville. When you talk to the JEA people, they've seen a large decrease in use of law, and they attribute it more to the application of water fees, okay? So which brings up, one of my favorite hobby horses and so forth, this inclusion of universal water fees as a way, as long as something is free, it's going to be abused. We have these people coming into Florida. Why? Because they're coming out of the West and said these dummies in Florida is giving it away water free. Let's go take it. And that's a major part of our problem. And they do this on a large scale. It's just corporate. The gentleman in front of me talked about direct potable reuse. There's enormous potential, not for direct potable reuse, but for recharge. From JEA alone, they're define it, but they could potentially increase their water use by 40% by using recharge water that has been polished, as it says, as they call it, by artificial wetlands and so forth, and returned back into the aquifer with precautions, as you said. That's hardly been anyway. My question is, do you think that universal water fees is going to help level out our water use?
Well, Bob, that was a whole mouthful.
I'm sitting here thinking, I have a few more too, but I can't.
So yes, the initial comment had to do with the sensitivity of demand to price. And there have been studies that have documented that, indeed, water demand is sensitivity. It's elastic with respect to price. And but that having said, who are those people who modify their demand for water? Turns out they're kind of middle-class folks. What turns out is the rich people, not so much, right? So those wealthy users really, they use the same amount regardless of the price of water. And then on the very bottom end, people who don't have much money, they're not really using a lot of discretionary water. And so their response to changes in prices is less elastic than people sort of in the middle of the income range. So yes, it's absolutely true. Would it be a good idea, as you point out, to institute some system of fees that would be levied on withdrawals from sources of water in Florida? I would endorse that. I think
tiered, we have to be tiered, obviously. Otherwise, people at the lower end would go first.
Yeah.
And actually put the push on people at the upper end. It becomes quite expensive.
Yeah, and it's absolutely true that for public water suppliers, and basically really for all water uses, what we pay for is two things: treatment and transmission. That's what we pay for. So the real value, for example, the real value expressed as the gross domestic product for the state of Florida, $850 billion, is not embodied in the costs for treatment and transmission. And in a lot of cases, some of the water that we're giving away, we're doing it at a loss. So for years now, reclaimed water, most utilities that got into it early were selling water to customers at a loss. So those aren't things that really are an especially good idea for promoting conservation for a very scarce resource.
We'll take one or two more questions if you have. Yes, Bob?
Oh, thank you. Could you back up to your summary slide? It's a couple of two slides back.
Somebody? I'm sorry.
There you go. Okay, your second bullet, pumping reduces discharge to natural systems, for example, springs. And I think your comment was this is not in contention. This is obvious, everyone accepts it. Not everyone accepts that. So if you look at Silver Springs, for instance, the water management districts say pumping reduces discharge from Silver Springs by 1 or 2%. Some trivial number. So my question is, the people in the water management districts that make those statements, are they ignorant or corrupt? They got to be one or the other, because you said that was not in contention.
Well, let me clarify that. It's not scientifically contentious. The scientists who don't have a stake in this and the outcome of how water is managed will all agree with that that's where the water comes
Why
from.
don't the water managers agree with that? It gets back to the question, are they ignorant or corrupt?
Well, Bob, that's a tough question to answer. I have a lot of good friends at the water management districts.
Well, they got to be one or the other. Those are the only choices.
I've answered that question before. We are enduring some very contentious political times. In order to survive, people are rephrasing their descriptions of the hydrology in ways to get by. Now, if you talk to them one-on-one, they know what's going on. They know exactly what's going on. But it's very difficult when we don't have that leadership all the way from the bottom, from communities, all the way up to the governor's mansion, to articulate what's really going on and talk to the people. You know, my friends at the Water Management District, they don't want to lose their jobs. They like working there. And I'm very sympathetic to the situation they're in. And so I'm not going to call them criminals or immoral or liars. I'm just going to say they're in a very tough situation. Yeah.
Jim, that was probably the most diplomatic answer I think anybody could have ever given to that question. And Bob Palmer, thank you very much. I can always depend on you. So, last question, Pam Smith.
Well, thank you, Jim. That was wonderful. On behalf of our Santa Fe River, we're very excited that you live on our advisory board, and we've never really had a chance to hear and speak. But you keep talking about we should strategically plan, we should do this, we should. That we, to me, is very, very nebulous, because obviously we've got the Itchitucky, we've got Santa Fe, we've got small organizations, we've got Florida Springs Council, which is now putting this together. But how do we push whoever we is to strategically plan and start thinking in terms of the fact that we're losing our most important natural resources? And since you have a bigger scope, global scope of everything, how would you see that movement happening, and what can the little guys like us do to push that to happen?
Yeah, a good question. How do we do strategic planning given the critical state of our water supplies across the state as a whole? So when I was saying we should be doing that, let me be more precise. This really needs to be orchestrated at a state level, but in coordination with regional and local governments, because the shock waves are going to emanate out in all directions. But it needs to be a state-led strategic planning effort, not just for water, but water resources in the context of our long-term knowledge about climate change and sea level rise. And what are we really going to be doing? What's going to happen, when that Category 5 hurricane hits Fort Lauderdale and the storm surge is so significant that the Biscayne Aquifer is inundated with saltwater, seawater, and totally destroys vast sections of the Biscayne Aquifer with ocean water? What are those people going to do? I mean, they're not going to drink water for who knows how long after that, because it's going to be salty. So these are the things that need to be orchestrated at a very broad effort. I don't think that we need a federal presence in this, although it certainly couldn't hurt, because these issues are global in nature. We really need a very strong state presence in leadership and doing the strategic planning in concert with local governments, cities and counties, and the water management districts. How do we get that how do we get that started? Well, here's my magic wand. Let it be done. It's a political question. it all will happen when we have political leadership that sees a need for it. Right? So go into that little ballot box and vote accordingly.
Jim, thank you very much. Pam and Renee, thank you again for hosting us, supporting this, and for all the work you and all the Water Resources Program people do at the college. Please feel free to stay, mingle, ask a couple more questions, talk to folks from our Santa Fe River and Itchitucknee Alliance, and I thank you all very much for your time this evening.